we are looking at, this is Unit 5, Part 2. Part 1 is what we tested on before Thanksgiving, the add, subtract, multiply, and divide polynomials. So for Unit 5, Part 2, what we're going to be focusing on is factoring. We're going to look at lots of different types of factoring, but today we're starting with the basics, GCF, okay, greatest common factor. So did anybody want to share what they thought or remembered that means? What is a greatest common factor? What is a factor? If I asked you for the factors of 6, what would you tell me? 2 and 3, or what else? 1 and 6. Those are factors. Okay, factors are what you could multiply together to get a number. Okay, or another way to think of it, it's what you can divide a number by evenly. So 6 can be divided by 6, 3, 2, and 1 evenly, right? And you still have an integer. That's what I mean when I say evenly. You get an integer answer, not a decimal or a fraction. Okay, so a factor is something, a number or a term that can be divided out evenly. What does greatest mean? The biggest, the largest. Okay, now common, if you have something in common, means it's the same, right? So that means there's going to be multiple terms, and we are looking for the largest factor that the terms have in common, that they share. Okay, so I'm going to write out that as my definition here. The largest number, or I'm going to put slash term, because it doesn't have to be a number, it could be a variable also. That can divide evenly out of every term in the expression. Okay, so for finding the greatest common factor, you're going to find the largest number that can divide into, or that should actually say out of, probably, out of the coefficients. So for the number, we're looking at the coefficients. Okay, so the largest number that can divide out of all the coefficients. So the coefficients, I'm just going to highlight, I'm going to kind of color code here for us, are the actual numbers. And that last one doesn't have any. Okay, so we're going to then look at the variables. Okay, we're going to find the variables that's the same in all the terms. Okay, so here we've got x cubed and x squared. Yes, I know that 3 and 2 are not the same, but the variable x is the same, right? That's what we're looking for. In this middle one, there's x and y. Those are not, so x, but there's no x here. Over here, we've got x and x. Now we've got a second variable, so I'll do that in a different color. Oop, that didn't change. Hang on one sec. Okay, and then over here, both terms have y. All right. So I'm asking myself, what can I actually divide both 6 and 10 by? So what if you need to list them out? List them out, the factors. I asked you the factors of 6. You told me 1, 6, 2, and 3. If it helps you to list them out, 1, 6, 2, and 3. Okay, what are the factors of 10? 1 times 10 would give me 10. What else? 5 and 2. Anything else? Or is that it? So do they have anything in common, those lists of factors? They both have 1, so that's common. Anything else? 2. So I'm going to just underline 1 was a common factor, but also 2 is a common factor. And we are looking for the largest. So is 1 or 2 larger? 2. So 2 is our GCF of the coefficient. So I'm dividing both of these by 2. Both of those can be divided by 2. That's what I want to show. If you don't need to show that, if you don't need to, I'm just showing that's what we're asking ourselves. So 2 for the coefficients, because both of those can be divided by 2 evenly. Now, what about the variables? So for the variables, these are both x. You're actually going to look for the lowest power because that's going to be the highest that they both have, right? The greatest that they both have will be the lowest overall. So we've got x cubed and x squared. So what's the lowest power there out of all the x terms? Squared. So I'm going to be able to take an x squared out of both of those. What I'm going to actually be able to do is divide out an x squared. I would not be able to divide x cubed out of this second term because the 3 would be bigger than the 2, right? I couldn't do that. So that's it. This is just asking what is the greatest common factor. So 2x squared is the GCF for this first one. That is what I could divide out of both of those terms evenly. So let's try that for the next one. Okay, again, you can list out the factors if you need to. Some of you don't need to. What can both 15 and 12 be divided by? They can both be divided by 3. If you're not sure if that's the greatest, list out the factors like we did. So what are the factors of 15? 1 and 15 and 3 and 5. Anything else? Okay, what are the factors of 12? 1 and 12 and 6 and 2 and 3 and 4. Good. So obviously everything has the common factor of 1. Anything besides 1, and the only thing that I see there that they both have is that 3. 3 is a factor of both, and that's the greatest common factor. Both of these I could divide by 3 and still get an integer, right? So 3 is the GCF of the coefficients. Now let's double check the variables. Can I divide an x out of both of these terms? No, the second term doesn't have an x, does it? Can I divide a y out of both of these terms? No, because the first term doesn't have a y. So the only thing that I could divide out of both of these is that 3. There is no variable portion of the GCF here. It's just the coefficient. Okay, and then this last one, there is no coefficient to look at, so no number to worry about dividing out. But what about the variable? So I could divide x out of both of these. They both have an x, but what is the lowest power between them? X to the 4th. So I could divide both of them by x to the 4th. Okay, so that's going to be the GCF of the x term. Okay, and then what about for the y's? Do they both have a y? What's the lowest exponent of the y's? So y cubed is the highest that we could divide out of both. So if I did this division, that would work out. So that is my GCF. So I found the greatest common factor. Now, you're most likely not going to be asked to do something that says just find the greatest common factor. Most likely you're going to be told to factor out the greatest common factor. Take the GCF out. Okay, so when we do that, we have to identify what is it that I could divide all of these by, but then I have to also write what's left over once I do that division. So you put the GCF out in front, and then in parentheses, you put the expression that's left once you do that division. So I wrote out the division that I was doing, but I didn't write what I was left with, the quotient, when I actually did the dividing. Okay. Now, if there is nothing that can be factored out, then we're going to say that it's prime. Can't be factored. Okay. So we're going to do the same thing, except we're actually going to write what we're left. We're going to write the factored form of the expression. So here, if you need to, you can. You know what? Before we jump into this, I'm going to do all my highlighting. If you're using highlighters or colored pens or pencils or something, you can go ahead and do that. I'm going to go ahead and get all my numbers, all my coefficients highlighted in green. I'm going to do all my x's, or all my first variables in blue. Then if you have a second variable, do it in a third color. I'm going to do pink. Okay, so my highlighting's done. All right. Now, I'm going to ask myself, I'm going to look at the coefficient first. What can I divide out of 3 and 15? What is the greatest common factor here for those numbers? Say it again. 3. The only factors of 3 are 3 and 1. And 3 happens to also be a factor of 15. So I can divide both of these by 3. Okay, so remember, I'm going to put my GCF, and then in parentheses, I'm going to put my leftovers. Okay, so I can divide out a 3, that's for sure. What about the variables? Can I take an x out of both of those? No, the second term doesn't have an x, so the 3 is all I can take out. So now I'm ready for the leftovers. Okay, so when I divide by 3, what is 3 divided by 3? It's a 1. Now, sometimes you have to write 1, sometimes you don't. Depends if there's any other terms that you're multiplying it by, right? Because if you have 1 times something, you can just write that something. The 1 is understood. The multiplying by 1 doesn't change anything. But if it's the only thing there, you do have to write the 1. So we're gonna see that throughout these examples. So here I'm left with x squared. So I do have a variable. Do I need to write 1x squared? No, this is a case where I can leave off the 1. It's an understood coefficient of 1. So I'm left with just x squared in that first term. Then there's a plus sign. And then what is 15 divided by 3? 5. Got my GCF and my leftovers. So far, so good? All right, let's try B. So what can I divide out of all of these numbers? 20, 100, and 5. What do they all have in common that they can all be divided by? 5. They're all divisible by 5. Now, we are leading with a negative. Our lead term is negative 20. When this is the case, there's technically two correct answers. You can leave it with the lead term negative, but we don't like to do that. So to get it factored the way that we want it, we want to be left with our leftovers to start with a positive. So I'm actually going to divide out that negative as well. So I'm going to put a negative 5 because I want that lead term to come out positive. And a negative divided by negative will give me a positive, right? Y'all agree? So I know I can factor out a negative 5. What about the variables? Can I take an x out of all of the terms there? No, that last one doesn't have an x. So even though these two have a common factor of x squared, this last one does not, and so I can't. It has to be able to be divided out of all of the terms. In this case, there's 3 terms. Okay, so no variable can come out. So I'm ready to put my leftovers. So I'm going to put, what do I get when I do that division? What is negative 20 divided by negative 5? 4, positive 4. The whole point was to get that to be a positive lead term. Okay, I didn't divide out any variables, so that's still x cubed. Now that was a positive 100, but I'm dividing by a negative, so what does it become? What's a positive divided by a negative? So this becomes minus instead of a plus there. What's 100 divided by 5? And that stays x squared. I didn't do anything to the variables. Okay, and a positive divided by a negative, we said is negative, so that's going to be a minus again. And what is 5 divided by 5? Yeah, anything divided by itself is 1. Okay, that reduces to a 1 or simplifies to a 1. This time I actually do have to write that 1 because there's no variable for it to be understood in front of, right? So I have to put the 1 this time. So far, so good? Now be sure and stop me if you have questions or something's confusing you. All right, in C, 24 and 12, what is their GCF? 12. So I know I can factor out a 12. Now what about the variables? Can I take an x out of both of these terms? Or excuse me, an a? Yeah, both of them have a. So what's the lowest exponent of the a's? An understood 1 right here. So just a is going to be able to be divided out of both of those. Okay, what about the second variable, b? Yeah, they both have b, but the lowest exponent of it is just that understood 1. So just b. So here's my GCF, 12AB. So now I'm ready to put my leftovers. What am I left with when I do this division? So what is 24 divided by 12? 2. Okay, what is a divided by a? What was up here? Y'all told me 5 divided by 5 was 1. So wouldn't a divided by a be the same thing? Anything divided by itself is 1. Okay, so even if it's letters instead of numbers, it's still a 1. So a over a reduces to just a 1. Okay, but we've already got a 2 here. So is 2 times 1 going to change anything? So I don't need to write the times. I don't need to write the 1. Still just a 2 there. Okay, now b squared divided by b. Do y'all remember your exponent rules? When you're dividing like bases, what do you do with the exponents, the powers? Subtract. So this is an understood power of 1. So what's 2 minus 1? It's just 1, right? So b to the first power, just b. b is all I'm left with. Okay, another way to think of this, if you are confused, remember, this is the rule. If you need to rewrite that rule, whatever that power on top is and that power on bottom, you're subtracting whatever that is. If you don't remember this rule, you can always write out all of the b's. So b squared is technically b times b, isn't it? That's what b squared means. So that one of those b's reduces with this b on the bottom, and I'm left with just b, right? So you can do that if that's easier for you. Same thing here, instead of a squared, if you actually needed to see that this is a times a, one of those a's is going to reduce with this a in the denominator, and you're going to be left with just a. Okay, if you don't realize that it's 2 minus 1, and it's just automatic a to the power of 1. Whichever way is easier for you to think about. All right, we've got our minus. What is 12 divided by 12? 1. A squared divided by a, we said is a. What's b divided by b? Anything divided by itself is 1. So the b's just completely reduce. Okay, that's a 1. And I don't have to write the 1 for the 12 over 12 or the b over b because they're both being multiplied. That would be 1 times a times 1. Multiplying by 1 is not going to change that a. It's just a. All right, let's try D. 25, 15, and 5. What is a GCF? What is a number that can divide out of 25, 15, and 5? 5. Okay, now let's look at the variables. Do all of the terms have x? All three have an x, right? What's the lowest exponent of the x's? 2, x squared. So that's going to be what I can divide out of all of them. Okay, they all have z. The lowest power is just the understood one, so just z. Then I'm ready to see what my leftovers are. What do I actually get when I do that division? What is 25 divided by 5? 5. X to the 4th divided by x squared. It's also x squared. Because if you do the 4 minus the 2, you get a 2. Or if you need to actually see this, this means x times x times x times x means there's 4 of them, and that means there's 2 of them. So we can see 2 of the ones from the numerator will reduce with what's in the denominator, and you're left with 2 of them, which is x squared, right? If you actually need to write out all your variables that way, you can. You're allowed. It's a little extra work, but you can do that if you need that visual. All right, then we've got our z's. What is z divided by z? 1. Anything divided by itself is 1. Do I need to write the 1? Is 5x squared times 1? Is times 1 going to change it? No, so I don't need to write the 1. And I've got a plus. What's 15 divided by 5? It goes faster when y'all participate. 15 divided by 5. It's 3. All right, x cubed divided by x squared. Just x, good. Z divided by z, that's an understood 1. I don't need to write it. Plus, what's 5 divided by 5? That's a 1. X squared divided by x squared. That's a 1. Z divided by z. That's also a 1. So all of those reduce. Okay, so that's just 1 times 1 times 1. What is that? It's just 1. So I do have to actually write the 1 here because there was nothing else with it. So you have to be sure you write the 1 in that situation. All right, last one we're going to try together. GCF of 6 and 3. What can both the 6 and the 3 be divided by? 3. Okay, they both have x. What is the lowest power of the x's? Yeah, it's just x to the understood first power, so just x. Okay, they both have y. What is the lowest y exponent? So y squared can be divided out of both. And then I'm ready for figuring out my leftovers. So what is 6 divided by 3? X squared divided by x. Good. Y squared divided by y squared. Yeah, that reduces to a 1. I don't need to write it because 2x times 1 is still just 2x. All right, what's 3 divided by 3? 1. X divided by x? 1. Y cubed divided by y squared. I'm left with a y there because the 3 minus 2 is 1. So y to the understood 1 power. I don't need to write the 1 that the 3 over 3 and the x over x reduced to because 1y is the same thing as y. My pen is not wanting to draw this box around my answer though. Here we go. All right. Y'all feeling okay with the GCF refresher? Greatest common factor. Okay, we're actually dividing when we do greatest common factor. We're dividing out whatever that GCF is and writing our leftovers in parentheses and the GCF out in front. That's our process. Everybody good with it? Now, if you flip over this paper, it says Unit 5, Part 2, GCF factoring notes on this side, and you flip over to the back, and it says factoring out GCF practice. Just trying to save some paper here since these were both the notes were just one-sided and this practice is one-sided, so I just put them on front and back of each other. So but I don't want you to turn your paper in because it's on your notes. I want you to keep this with your notes. So you're going to do your work. You're practicing GCF factoring here, okay? And then you're going to submit your answers. You're going to log into Delta Math and you'll see the assignment for this where you're actually going to type in your answers. But this is a place for you to do your work, show your work, do your scratch work, get your answers, and then you'll log into Delta Math to type them in and submit. I have set it for the Delta Math to give you 3 attempts. Like it'll give you the little warning that says that's not right. Find your mistake, try again. So when you get your GCF, if you write it out, you'll be able to see, uh-oh, I did something wrong, and you can come back and try to fix it. Or you can maybe see, is it just a typo or something like that? But you'll get 2 warnings. You'll be able to do that twice and get 2 warnings. And then the third thing you type in, if it's still wrong, then it's counting it wrong and you're losing points. Make sense? Okay. So that's what y'all are working on for the rest of class. And then don't forget that you have the Delta Math, the like prior knowledge and skills assignment for this factoring stuff that you were assigned the Friday before Thanksgiving. That is due tonight before midnight. Okay, so if you want to go double check that you have submitted that, you can do that first and then start on your GCF practice. I'll leave that up to you. Okay, this GCF practice will need to be submitted in Delta Math. Today is Tuesday, so by Thursday before midnight. Okay. All right, y'all get to it.